Interested in air assist? Looking for some answers? Well, stick around because that's what we're going through in this episode. Hey everyone, and welcome to another episode of James Dean Designs. If you're into laser and CNC work, make sure you hit that subscribe button in the corner to get all the latest videos. Now, I've mentioned air assist a lot in my laser videos, and it's one of those pieces of advice where I always say to people, make sure you're using air assist. But not everyone understands exactly what it is, and that's exactly what we're going to cover in today's episode. We're going to take a look at what air assist is, the various options you have to create some sort of air assist, do some testing with it, and ultimately show you the differences between air assist, no air assist, and the various things in between, and also try and tackle some of the myths around air assist as well. Now, everything I'm going to feature in today's episode, the different pumps and air assist nozzles, I'll put links in the description area below. Do check it out, it's where I put lots of useful information and links all related to today's video. Now, let's start with the basics and move on and take a look at what air assist actually is. So I just wanted to quickly interrupt the video. I've been having some microphone issues recently, and it wasn't until I started playing all this footage back in post-production that I realised there's some rumbling and popping going on with the microphone because I'm essentially looking down as I'm talking and doing these demonstrations. So I just wanted to apologise up front for that. Most of you probably won't even notice with the editing that I've managed to do, but also I wanted to assure you this will get better in future videos. So air assist in its most basic form is some sort of airflow around the laser as it's operating, typically between the lens and where it engages with your material. Now, there are a few reasons that this is important. If you imagine as your laser is engaging with the material, you will get smoke coming up straight into the direction of the laser lens itself. Now, there are two important things going on here. One, as the laser beam travels through that smoke, it's basically getting diffused. So by the time it hits your material, it's less powerful and less efficient. So it's having to work harder to do the same job. The other thing is, as the smoke rises up, it's going to settle and deposit on the lens of the laser itself. So this will make the laser lens dirty, which in itself has downsides and side effects. Again, the laser traveling through the lens is going to be less efficient because it's having to pass through something else in order to reach your material. But more importantly, that build-up on the lens will eventually start to get hot by the laser passing through it. So you run the risk of the laser lens cracking itself if the build-up gets too much. The build-up will also affect other areas around it, such as the body of the laser and the holding rings that sit to hold the lens in place. Another advantage is, as the laser is burning the material, it's going to generate heat. That heat eventually starts to lead to scorch marks and overburn going on around the area that it's operating in. The air assist helps to keep the material cool whilst the laser is just burning the area that it needs to. So in essence, you get a cleaner finish by using the air assist. Also, when the burning takes place, it will start to generate like ash and residue. If your air assist is strong enough, it will help move that residue out the way, again just helping the laser to be more efficient. So now we understand the basics about it, we can start to move on and take a look at the various methods that we can implement to get some sort of air assist going on around our laser. But before we move on, I just want to reference that most lasers you'll be using have some sort of fan on top. Now, these are low powered fans, they're there to keep the laser cool. But what it will be doing is creating a downdraft in some of the slots down the side of the laser, obviously to keep it cool, but that airflow will hit the bottom of the laser. You often find you may get the smoke going off to one particular side of the laser, and this is the reason why. Now, don't consider this to be an air assist, although it is technically creating an airflow around your laser, but it's just an explanation as to why you may feel some sort of draft underneath your laser when it's operating. So now let's move on and take a look at those various options that we have got for air assist. One of the cheapest and most basic options is to have something like a handheld fan or a desk fan just sitting next to your work as it's operating. Obviously, as the fan's spinning, it will generate a flow of air across the top of your material, which will keep the smoke out of the way, blowing it in one particular direction. Now, there are some downsides to this, and we'll cover this later while we are testing, but as I say, it is the cheapest and easiest option just to use a fan to create that airflow along the top of your material. The next cheapest option is something like a fish tank air pump. Now, these are relatively cheap. You can pick them up off of Amazon for things like around $15 or $20. They do come in varying strengths though, so pay attention to the specification when you're buying them. Sometimes they're measured in how many litres per minute, sometimes they might be measured by PSI. Ultimately, you want to try and get the strongest one you can for your budget, but as we've already mentioned, any air assist is better than no air assist. Now the way these work is obviously they suck air in, blow them out of their tubes at the end. You would then put that tube as close to the laser as you can, obviously without getting in the way of the beam, to direct that jet of air where it's engaging with your material. These can just be zip tied or held in place with something to try and get that jet of air quite close, or we can use something called an air assist nozzle. Now an air assist nozzle is basically a device that fits over the end of your lens, and it just allows that jet of air to be a bit more precise when it's engaging with the material. This is just a very cheap 3D printed one that I've done. You can buy better ones, and again I'll put more links down in the description area to buy ones that are machined out of brass. Ultimately though, what it essentially does, as I say, it just keeps that flow of air more direct as to where it's engaging with the material. So you're not really wasting any air by it just flowing elsewhere. So if you're after something a little bit more powerful but without breaking the bank, you can start to look at an air assist pump. Now these basically do exactly the same job. The only difference is the airflow between them. This one will output twice as much air as this one, so technically it's twice as powerful as the fish tank pump. There are also additional advantages to these air assist pumps. One, obviously you can turn them on and off and you've got a variable dial to adjust the pressure, but the power cable can be fed straight into your control board if your control board takes it. And what that basically means is that you can have the air assist turn on and off as your laser job starts and finishes. So it's just one less thing to worry about and making your life that little bit easier. Now for me this unit is sufficient and I haven't needed to go any higher in terms of pressure, but there are two additional steps that you can take if you want more pressure. The image that I've just put on screen now is basically like a desktop compressor. It is a small compressor that can sit alongside your machine with a higher output in terms of the pressure that it can release. They are typically noisier, but as I say, you will get a higher pressure. Now the next step up from that is going on to a full size compressor. Now the downside to this is, one, they typically are really noisy. Two, they also take up a lot of space and people can't always store them next to their laser. So ideally, if you're in the market for an air assist, I would typically go for something like this or a desktop compressor. So as with most things, we have cheap options and we have more expensive options. Now ultimately your budget probably decides what route you go down, but does it mean the cheap option isn't worth it? Does it mean the highest pressure is going to get us the best results? Well, that's exactly what we're about to find out in the next segment. I'm going to be doing a series of tests to try and show you the results of the different options that we have available. I'm going to be using both the SaintSmart LE1620 laser and the FoxAlien 5W laser to do a series of tests. Now I'm not comparing the lasers between them, I'm doing separate tests across them but just speeding it up by using both lasers at the same time. Ultimately though, we're going to be doing the same set of 4 tests across various options. We're going to be comparing the handheld fan with the low powered fish tank pump, the higher powered air assist pump, and ultimately comparing those 3 against no air assist at all. So I can start to show you the physical differences between them and also the expectation of the results between the different options that we have. So let's get stuck in and see what the tests show us. So the first test that we did is a power scale test, and the way this works is just the power of the laser against the different speeds that it is travelling, and you get this gradient effect where as the laser is using less power and travelling faster, ultimately it's having less of an effect on the material that it's engraving. If you want to know more about power scale tests, check out the link in the corners of the previous video I did on how to make these and how to see what it is you're looking at and where you judge what is roughly the best results for your laser. Now the 4 tests that we did are the handheld fan, the low powered pump, the high powered pump and no air assist at all. And straight away there are 2 fairly obvious things from this particular test. The first is all this scorch mark around the bottom right hand corner, particularly on the handheld fan and the no air assist. It is much worse on the no air assist, it's much darker. What these yellow marks are basically scorch marks from where too much heat is going into the material, and it ends up making everything look a bit dirty and a little bit messy. Now there are slight markings on the low pressured pump, but they're really not that bad, and on the higher pressured pump there's no markings at all. So again, it just proves that the higher powered pump has a better result. The other thing to note as well is if we take a look at around the 30% to the 20% columns, there are some differences. So on the handheld fan, the 30% goes up to about 1400, 1500 before it starts to really drop off. If we come down to the high powered pump, this goes up to more like 16 or 1700 before it starts to drop off. And equally with no air assist at all, this is really down the bottom within the first two boxes, and then it starts to drop off after that. So again, it's showing the efficiency of the laser. If we take a look at the 20% column, there's no markings on the handheld fan, there's no markings on the low powered pump, but we do have slight markings on the higher powered pump, again, just helping the efficiency at those lower percentage powers. There is a slight marking on the no air assist at all. I think this is where there's a slight change in the grain pattern, and that's why it's showing up. Obviously, the grain of your wood can make a difference to the laser engravings when you're doing them, because certain areas of the wood will engrave better than others. The other thing we can see is in the top right hand corner of the higher powered pump, the depth of the black is darker than it is on the no air assist, and again it just emphasises the point that the laser is working more efficiently when you're using the air assist. So the next test is also a power scale test, but for cutting at this time. So as opposed to engraving the surface, we're looking for how well the laser is fully penetrating the material, but same principle of power versus the speed it's travelling. The cutting order is also exactly the same, so handheld fan, low powered pump, high powered pump, and no air assist at all. Now what we can see straight away is the handheld fan, low powered pump and no air assist at all, and pretty much all cutting around the same parameters. So we've got the two bottom lines taken out on both and the first couple of the third line. The handheld fan did have one extra piece fall out. I should also mention I haven't tried to force any of these out. Basically if they didn't shake out, that's how I left it. So we can see that these three are pretty much performing the same. But the difference is the amount of overburn on them. So we've got quite a bit of overburn on the handheld fan. We've got a bit of overburn going on up here as well. But interestingly, not quite as much on the part where it has penetrated. The one big anomaly for me here is the one with no air assist at all, almost has no overburn. So that is quite odd. The main point now of this particular test is the higher powered pump has cut much better. So we've got the first three lines completely taken out and part of the fourth line also taken out. So yeah, it just indicates that the bit of extra pressure in that pump is assisting better with the cutting of the material. So I continued with the cutting test, but on this variation I did 2 passes per square as opposed to the last test where we just did 1 pass per square. Because of doing 2 passes as well, I took the speed range up slightly, knowing that it could handle these slightly higher speeds. The cutting order is exactly the same as well, and the results are more in line with what I expected. So the handheld fan has done pretty well. We've got 7 squares remaining. The low powered pump has done even better with 5 squares remaining. The high powered pump has only 4 squares left, and the no air assist at all only just about completed half of the selected grid. The overburn is similar to the last results as well. There's hardly any on the high powered pump. A little bit going on the handheld fan because it's directional as well, blowing all the heat in one particular direction, whichever way the fan was sitting. So the takeaway really from this is that the air assist probably has more benefit when you're doing multiple passes as opposed to single passes when doing cutting. So logically at this point you're naturally thinking, well, the higher pressure of the pump is going to equal better results when cutting, and that's exactly what I was thinking. So as a bit of a test, I connected the air assist tube up to my full size compressor. Now the output of this was probably running somewhere between 60 and 70 psi. I didn't fully measure it when we were doing it. I just assumed that it was going to cut a lot better. But the result I got really threw me off. So what we can see on this bottom, the bottom cut is the single pass and the top cut is the double pass. Now we can actually see it's performed worse than any of the other tests that we did. So if I bring this down slightly and put it next to the air assist test that we did originally, that's the double pass on the high powered pump, that's the double pass on the full air compressor. We can see that it hasn't even completed half of the grid. So actually there is a point where too much pressure becomes a bad thing. I've heard 30 psi referenced before, so maybe that is the midway point where you're aiming for. but certainly using the full pressure of a big compressor isn't going to get you any better results. So the next test was a photo engraving on a painted tile. This is a white tile spray painted black, and then as you laser over the top, you're basically taking the top layer of paint off the tile to reveal the white colour underneath. Now same cutting order again, handheld, low powered, high powered and no air assist at all. They're all pretty much the same. I should say the handheld fan is slightly darker on the left hand side of the image. I'm putting this down maybe to the direction of the air blowing across it, but yeah, that one is the slight anomaly in this test. The quality of the engravings themselves are all pretty much the same. The high powered pump, is probably slightly the cleanest. There's less lines through the image itself, so it does look the tidiest, but there's not a huge amount of difference in the quality of the engravings itself. So for the next test, I had to play about with some line art. Now this is a single line vector, and obviously as the laser follows it, it gives you the chance to play about and take a look at the detail of lots of lines together versus as they spread out farther apart. Also allows you to check how sharp your laser is actually engraving, especially in these pointy bits where it does a little traverse move. Same cutting order again, we have handheld, low powered, high powered and no air assist at all. Now for the most part, these two have performed pretty much the same. The high powered one is a little bit cleaner. There is less overburn around the circle in the middle, and the darkness of the lines are slightly better with these two. The handheld fan, we've got a little bit of overburn going on around the middle, but the worst performing one by far was no air assist at all. There's little lines in the little gaps in the lines where it's performed. Now again, this can be part of the features of the grain, but there's a significant difference with how well this is engraved versus how well the high powered pump is engraved. So just confirming the results that we've seen so far already. So I hadn't planned to feature this experiment in the video, but the results were quite surprising, and I thought it best to show you just because it slightly disproves a bit of a theory out there. Now this is 5.5mm thick plywood, and typically when you're cutting thicker material, what you would expect to do is lower the z-axis down slightly every pass that you're taking. So in this experiment, obviously there's 4 passes, 5 passes, 6 passes and so on. The first experiment that I did, I lowered the z-axis down at 0.5mm every time. And what this basically means is the focal point of the laser, where it's most efficient, drops through the wood as you're cutting it. So in theory, it is more efficient when you're cutting because the focal point gets lower into the material itself. Now as we can see here, on this experiment where it was dropping at 0.5mm every time, it took 8 passes before it cut fully through the material. Now as a hunch, I turned that feature off and just ran it normally. So this just did continual passes without dropping the z-axis, and it cut through after 6 passes. So that's quite a bit of difference between the two of them. Now as I say, that goes against what the traditional theories that often people say, where the z-axis should lower down. From my experimenting, it actually proved better not to lower the z-axis. This might be slightly different when you're using something like a CO2 laser, but in this scenario it works better to keep the z-axis consistent. Now the example up here is doing exactly the same, no drops and no air assist at all. We can see obviously it's got quite messy with all the overburn that's going on around them, but also again it took 8 passes to cut as opposed to 6 passes with the air assist. So that high pressure compressor test was really playing on my mind because I was expecting better results from it. I went back and did exactly the same test, but turned the pressure down on the compressor to around 40 psi, which is around the lowest my regulator will actually go. Did the test again and got exactly the same result, 6 squares taken out. So it has confused me slightly because I was always under the impression the higher the pressure, the better result you were going to get. Now if you're into this thing or you do a lot more work with the compressors on the lasers, then do let me know if there is some sort of cut off or the physics behind it as to why it is less efficient the more pressure that's putting on it. Let me know in the comments section below, I'd love to read up on that. Now what does everything mean that we've gone through? What is the conclusion today? Well, we've clearly seen that having some sort of air assist is better than no air assist at all. Not necessarily because of the results on the material, but the laser itself. Obviously blowing the smoke out the way means the laser can perform more efficiently, and it stops all that residue building up on the lens, which ultimately can cause damage to your laser. So definitely air assist over no air assist 100%. As for the pumps themselves, well, is there a difference? Yes, we've clearly seen that as well. The higher pressured air assist pump perform much better than the smaller fish tank pump, but equally there's still a difference between the price, and if you can only afford the smaller pump, definitely do get that because you will still see the benefits to it. Now, obviously I haven't been able to do the test with the smaller desktop compressors today, but if I'm perfectly honest, I don't see the need to, because the results I got from the small air assist pump have been brilliant. It's small, it's compact, it can sit inside your enclosure, it's not too noisy, so it's not going to be adding all that extra noise that a compressor would add, which obviously is one of the benefits to having a laser, is they're quieter over things like CNC machines. So yeah, we've got some useful results and some useful answers from today's video. Hopefully you've liked it as well. If you have, please make sure you subscribe and hit that like button. It really helps out the channel the more likes and interaction I get, so yeah, please give it a thumbs up. Thank you very much for watching. Final thanks as always goes to my patrons. You really help keep this channel going. Thank you very much. I'll see everyone on the next episode.